All right, here I go with another solution to a released AP exam question. This question is different than any of the questions that I've recorded previously in that this question includes a paragraph length response for a part of the question. So when we get there, I'm definitely going to kind of just try to do my best to give some general advice for how to tackle those questions in general, and then specifically answer this question. So let's get to work here. The question provides us with a diagram that looks pretty straightforward. I'll just read into it so that we can kind of make sense of this. So we have two identical spheres that are released from a device at time t equals 0 from the same height. Okay, so same height h, released at time t0, as shown above. So sphere A has no initial velocity. So with no initial velocity, it is going to fall straight down as shown in the diagram. Sphere B is given an initial horizontal velocity of magnitude v0 and travels a horizontal distance d before it reaches the ground. So it will move in this kind of parabolic path familiar to us from projectile motion. The spheres reach the ground at the same time, t final, or tf. So they do hit the ground at the same time, which is exactly what we would expect. But it's pointing out even though sphere B has more distance to cover before landing. So they're just pointing this out to us. There's really no question yet. They're saying, no, they did hit the ground at the same time, but interesting, sphere B had to travel a greater distance. And a friendly reminder that the word distance means length of path traveled. So certainly this straight down path for path A is a shorter distance than the path shown for B. It's a longer path. So this is true. All right, A resistance is negligible as we typically expect. So part A says the dots below represent A and B. Draw a free body diagram showing and labeling the forces, not components, exerted on each sphere at a time of t final divided by 2. So I don't think that there's anything unique about this particular time. I suspect the reason that they're honing in on any particular time is they just want to stress that this is after both spheres have been released, but before either of them have hit the ground, or really before both of them hit the ground, because they do that at the same time. So they're just like mid-flight, if you will, as far as this free body diagram is concerned. So this should be very straightforward for us. Sphere A, the one that falls straight down, has a downward force of gravity, so I'll just show that as a vector, and I will label that with maybe F gravity. That's my notation that I like to use, but again, any familiar notation would have been accepted there. And sphere B is actually, as far as forces are concerned, it's in the exact same situation. The only force on it is similarly the force of gravity. So maybe I'll call that the force of gravity B, and I can call this the force of gravity A, just to clarify that those are two separate bodies, two separate forces. But it's true. They both have a singular force, or each of them has a singular force, a downward force of gravity. All right, so that's really all that we have to do for part A, and just a reminder, answer the question and move on. They didn't ask me to explain. They didn't ask me to calculate anything. They didn't really ask for anything beyond draw in the forces. So I've done it. I'm moving on, and I'm not going to add anything else to this diagram. I'm not going to add velocity vectors. I'm not going to add acceleration vectors. Doing so would be a big no-no when you're asked to draw a free body diagram. So forces and nothing but forces as shown. All right, part B. On the axes below, so we have it does say horizontal component of velocity with time. Sketch and label a graph of the horizontal component of the velocity of sphere A and sphere B as a function of time. So we have velocity time graph, although to be clear, it's just a horizontal component of velocity time. So this should also be really straightforward. Sphere A dropped vertically down will have 0 horizontal component of velocity at all times. It doesn't go sideways at all. So this should be quite straightforward. The velocity is 0 horizontally, and it remains 0 throughout the whole fall. Something like that. And maybe I will just label that. Actually, an arrowhead probably isn't needed because actually that was kind of an accident. It deleted the whole thing. It doesn't like go on forever. It's just for some duration of time. I don't know. I'll just go to the end of their grid and mark that as sphere A. So maybe just label it A. And the other sphere, sphere B, is the one that was projected sideways. So it does have a non-zero velocity horizontal component, But with no horizontal forces, that horizontal component will remain constant. So constant, but not zero. So again, this is a sketch of a graph. I'm not worried about specific values, that are not zero. So it doesn't really matter where I pick this. I'll just go somewhere in the middle here, just arbitrarily. And I will just kind of sketch this out again horizontally. Okay, so there we go. Ideally, I'd be using a straight edge, but that's a little hard to do on a tablet, so I'm just kind of freehanding it. But preferably, those would be perfectly straight and horizontal lines for both of them. So that's it. Friendly reminder, on a velocity time graph, the slope is the acceleration. So you can see that there is zero acceleration for both of them in the horizontal. And let's not confuse this. I haven't been asked anything about the vertical component of motion, so I'm not going to try to bring that into play at all here. So that's it, part B. Okay, now part C is where things get a bit more interesting, and I've already written this up ahead of time. Rather than write up a paragraph and have you, painfully watching me write it up, I actually typed it up ahead of time to save myself and you the time. So let me just kind of reveal the question here, and in blue, I'll scroll into it right away, but let's just hold off on it. Let's just have a look at the question. It says, in a clear, and this is very standard wording on this kind of a question, in a clear, coherent paragraph length, so those are three separate parameters, each of which is important. Explain why the spheres reach the ground at the same time. So we're not even being asked, do they, right? We've already been told that they do. We're now being asked to explain why the spheres reach the ground at the same time, even though they travel different distances. Include references to your answers to parts A and B. Okay, so being the first time that I'm going through, in a video response at least, a paragraph length question, let's just have a quick chat about that. So the point of the paragraph length question, just in the most general sense, is to give you the opportunity to convince the people grading your exam of more than one thing. Number one, you are being tested, of course, to see if you actually understand physics. Now, that's not unique in any way to a paragraph length question. You're continually being tested if you understand physics with multiple choice questions and, shorter response questions as well. So that's not unique to the paragraph length. The thing that is, maybe I shouldn't say unique, but is especially true of the paragraph length response questions, though, is to see if you can communicate to somebody else your thought process. How is it exactly that you're able to, explain something, or in a different question to justify something? So this question basically saying this is the way it is, explain it. It's not uncommon in different questions to ask maybe there are more than one possibility. Which possibility is it? Explain your choice in a paragraph length response. So we are going to have to work really hard to make sure that we're clearly communicating. A few general tips for you. Number one, you don't have to write this like an essay. In fact, I would say do not try to write it like an essay. Try to be brief, but be clear and concise. So you want to get the facts that are relevant into the answer. You don't want to bring anything that's irrelevant. You don't want to be repetitive. You just want to get the answer done. So just prove to them that you get it. As a general guideline, you should be aiming for somebody to read your question, like once you've written it up, and they should be able to read it understanding your thought process. Okay, so you should lay it out clearly in a nice orderly fashion. It should flow. So let's test that with my own answer that, as I said, I already wrote up ahead of time. Let's just read it through together like once from beginning to end, and then we'll just reflect upon it and talk about it a bit more. Okay, so here's my answer. And of course, this is just my answer. It's not like this is the exact way that you'd have to write it up. There's some latitude into how you communicate your thoughts. But nonetheless, I would say that this is an example of a hopefully good response. So here's my answer in full. The motion of sphere B can be resolved into a horizontal component and a vertical component. So just to remind you, sphere B is the one that went in the parabolic path. So yes, we can resolve that one into two components. These two components of motion are independent of each other, so sphere B's horizontal motion does not affect its vertical component of motion. The vertical component of motion for sphere B is identical to the motion of sphere A, since both start with zero velocity, vertical velocity I should say, fall with the same acceleration of free fall, i.e. 9.8 meters per second squared, since each sphere has only a gravitational force, as seen in part A above, and undergo the same vertical displacement since they were dropped from the same height above the ground. They will therefore take the same amount of time to move to the ground. The two balls were released at the same time, t equals 0, so since they both take the same amount of time to move to the ground, they will reach the ground at the same time, t final. First of all, you might wonder if I wrote a paragraph, or if this is 3 small paragraphs, or what it is. Just realize, and I think that this is important, you shouldn't take the word paragraph too literally. It's not like you have to start with like an indentation and then write a whole bunch of sentences and be done with it. It doesn't have to be structured in that quote unquote paragraph way. So the way I broke it up into 3 little mini sections here, I think is completely acceptable. They're not really grading for that, like that level of minutia in your writing. It is, however, important that I'm writing sentences. It would not have been acceptable for me to just try to throw this down into some kind of a mathematical, explanation here of just, math, look at the answer, there it is, walk away. We are trying to communicate. So this is my answer, and I claim it's an example of a good answer. And for this question, let me actually show you how this question was scored, okay, or the official scoring guideline. In fact, let's look at the scoring guideline and see, in fact, if I have satisfied all of the requirements that they were looking for in this question. So just below, I actually have what each point allocated to this part of the question was. This was actually, the whole question was a 7-point question, and 5 of those 7 points right here were allocated just for this part C. It was actually only worth 1 mark to get this whole idea of the 2 graphs right. This was 1 single mark for both A and B, and it was also 1 single mark for both of these force diagrams. So really, it was 1 point for A, 1 point for B, and then of this 7-mark question, it was 5 marks here. So you can see that the paragraph length responses can be worth quite a lot. Okay, so how did I do? Let's have a look at it. The first point says, 1 point for indicating that the difference in horizontal motion does not affect the vertical motion. So this point, in effect, is saying, in your paragraph length answer, you have to clearly explain, or at least state, that the 2 components of motion are separate from each other. Did I do that? The answer is yes, I did. I talked about how it can be resolved into horizontal component, and these 2 components of motion are independent. Okay, so just from saying that right there, these 2 components of motion are independent of each other, so blah, 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 would basically satisfy. In fact, let's do it this way. I didn't think this through. Let's color code this. That'll be a nice way to do it. So let's look at this 1 point here for indicating the difference in horizontal motion. And I would say that, yeah, right here, it can be resolved into the 2 horizontal components, and they are independent of each other, blah, blah, blah. Okay, so just to get the idea, I think I'll just kind of point it out there. So everywhere between those red square brackets, I think is where you can really hone in on to get that point. Let's have a look at the next point. So I'll just switch to another color here. Let's use green. Okay, so 1 point for indicating that both start with the same vertical velocity. Okay, so I had to have communicated that. It's important to realize that they have the same, among other things, vertical velocity. So I said right here, the vertical component of motion for a sphere. Okay, right here, yeah. The vertical component of motion for B is identical to the motion of sphere A, since they both start with 0 vertical velocity. Okay, so roughly in there. I think that I've satisfied that requirement. What else did we have to say? Let's switch to, try this one, a purple, if that shows through. It's not a very vibrant purple, but it stands out, I hope. Indicating that they have the same vertical acceleration. In fact, I strung that together essentially in the same sentence, but you can see it right here. They fall with the same acceleration. I didn't even have to specify that it was, free fall 9.8. It would have been enough to just say they have the same acceleration. So, of course, you don't know when you're writing your paragraph length answer exactly what they're looking for, so you are advised to include all relevant, details. Okay, so you don't have to go completely crazy. Nobody's expecting you to be a mind reader of what little nuance they're looking for, but certainly anything that is relevant physics that you would have learned in this course should be included. Okay, what else do we have to do here? Switch over to an orange. 1 point for indicating that they fall the same height. So falling the same height would take the same time. Undergo the same vertical displacement, right here. So undergo the same vertical displacement. So they therefore take the same amount of time. Okay, so somewhere's in there between those two orange brackets there. I think that I've satisfied that requirement. Okay, now check this out. This is actually really neat, this last point. So let me just switch over to, I guess, I'll just highlight this one with pink. So 1 point. Now, notice that this 1 point doesn't say for doing something. In effect, it is saying for not doing something. That's really interesting, hey? So 1 point for having no incorrect or irrelevant statements. So imagine that I came up here and I was just trying to shovel it on. I mean, I'm just trying to throw anything I can think of in here. Imagine if I were to be writing in here oh, by the way, the spheres are, well, I don't know. I guess you'd have to really think of something crazy here, because if I said they're electrically neutral and good thing they're not conductors and they're insulators. I mean, none of that would have any relevance to this question, right? So if I was just throwing things in here that had no relevance, it could actually harm my scoring potential. And definitely if I had anything incorrect in here, imagine if I said, for example, well, good thing that they have the same mass as each other, because boy, if one of them was heavier than the other one, then they wouldn't have taken the same time to fall. That would be wrong, okay? It's actually not important that they had the same mass, because this is an idealized condition fall. So if I would have said that, even if everything else was good, if I had said good thing they were the same mass, because otherwise it wouldn't have worked out, I would have lost this mark, because my answer would have included an incorrect statement. So there you go. Hopefully that's of some help to you in terms of how to approach a paragraph length response. Just to summarize here, clearly communicate, bring in fact, I don't think I said it this way before, bring in the correct physics that you learned in your course and apply it to the specifics of the question you're dealing with.